Good afternoon, good evening, or good morning from wherever you're joining us from today. My name is Sarah and I'm the Program and Event Manager at the Reactor in Sydney, Australia. Welcome to another Microsoft Reactor Sydney live stream event. Today I would like to welcome back Brad McCoy. Brad is the Cloud Engineering Lead at Moula. He started his career as a software engineer and transitioned into DevOps. He is passionate about Kubernetes and open source technology. Today, he will be doing a technical demonstration of deploying .NET 5 microservices to Azure Kubernetes Service with Terraform and Helm. This session will be 60 minutes today with about 10 minutes for questions at the end. However, do send us your questions throughout in the Q&A section, and between Brad and myself, we'll try and answer as many as possible. At the conclusion of this session, we'll share a link to the feedback survey in the Q&A. If you have a chance to answer that, that would be great. And we'll share with you the event code as well. And if there's anything that you've missed from today, there will be an on-demand version uploaded to our YouTube channel in the next 24 to 48 hours. But for now, I'd like to hand the floor over to Brad to begin. So Brad, thank you, and over to you.
Thanks, Sarah. Welcome, everybody. Today, we'll be doing a lab on deploying .NET 5 microservices to AKS with Terraform and Helm. So this one will be quite a technical session. We'll look at more code than slides today. If you have any areas that you want to cover while I'm doing it, please ask in the questions and I'll try my hardest to show a demonstration of that or to answer those questions as we go. So yeah, expected outcomes for today. We will provision all the Azure infrastructure that we need with Terraform. So we'll just have a basic setup where we'll have a virtual network, subnets. I decided not to use ACR today, but we can. We'll have AKS and Azure Active Directory as well. And then we'll create a .NET 5 API and push to Docker Hub, just to make it a little bit easier, because 60 minutes is not much time to do all this. And then we'll create a Helm chart also for the API, and then we can deploy the API using Helm to our Kubernetes cluster. And then at the end, we'll create the API. So I've got a few links. There's a blog that I've written for this that's in the meetup page. So that has instructions if you want to do this after today. If you have any questions, please reach out to me. I'm happy to answer them afterwards as well. When I tried this lab, I used the Microsoft free account, but I had issues with compute quotas with the Kubernetes clusters, so I just have to figure out the right instance size to use for that. So I'll update that after the lab. And yeah, so we'll probably spend about 15 minutes on Terraform, 30 minutes on Kubernetes, the API and Helm, and then we'll follow up with a Q&A session afterwards. And presenter, and then yeah, let's also, if anyone wants to attend KubeCon tonight, there's so this is a CNCF group as well, but we're sort of in partnership with Reactor, so thanks for the CNCF people that came to here as well. And if anyone wants 25% off, that's the code there, QCEUVMeet25. You can take a screenshot of that or ask me later. All right, so let's get started. So here's the lab that we're going to go with. So you can see that in the meetup page. First of all, yeah, if you need a free Azure account, you can follow the links here. I'm sure that's pretty easy to set up. So all of the code today I've got in my GitHub. So you can see here we have one repository for Terraform. That's at this link here. And then we have one for the API as well. So if you, after this lab, want set up your own cluster, or you want to use a .NET 5 API, you're more than welcome to fork this. You can just click the fork button there, and then you can make it your own. You can change things and just, you know, continue to learn if that's something that interests you. So yeah, you can fork those two there. The dependencies that we'll need locally, Terraform, Helm 3, Azure CLI, and then Docker desktop as well to build the Docker image. And in this case, I'm using remote state. So you don't really need to use remote state. You can just use state locally. If you do just want to use it locally, you can just take out the provider, which I'll show you soon in Terraform. So today we'll go through the remote state. Essentially just lets you store the state file that's not on your computer so other people can use it, or you're not going to accidentally delete it. So here you can see that we can create a resource group with a CLI, a storage account, and then create a storage container as well, which will hold that file. So let's start to look into the code. So here you can see this is inside the AKS Git repository that I made. There's different ways you can make Terraform. You can do modules. You can do Terraform Cloud. You can do all sorts of ways. This way, when I do small projects, I like to keep it sort of modularized in terms of naming files. So because this is quite a small project, it's just easy to say, if I want to make a change, I can go to network. So the main basics of Terraform is you have a provider. So this one, we're using the Azure RM. So that's essentially just the Terraform provider for Azure. So any resource that we want to do in Azure, we can find, and we can find that online at the Terraform. They have great documentation. If you go to just Terraform IO, so you can see all the modules and stuff here as well. So it's just one of HashiCorp's products. Most of you know that. And then they have great documentation of all the infrastructure you need. So if there's anything that you want to deploy, you can come and look here and you'll see. So we also have a Kubernetes provider as well. This is what you don't really need to use that, but if for some reason you did want to have Kubernetes resources in Terraform, you can leverage this. So after the Kubernetes cluster has been done, you can then use the output variables for that to then connect to it, and then maybe you want to run create namespaces or secrets, or most people keep those separated, but yeah, there is a Kubernetes provider as well. So first of all, we'll start here. Okay, so let's go over the variables. So in Terraform, we have something called variables. So variables can change. So instead of hard coding everything, we want to make everything modular and reusable. So here you'll see we have basic, client ID, project ID, environment. You can also use Terraform workspaces as well. That we'll sort of do that in a better way, but for this demo, we'll do it just here. So here you can see that we're using Calico for the networking Kubernetes. We can specify node count and the node size of the VMs that we want to run. So this is where I'm saying this won't work using the free account. So I'll have to do some research to see what ones we can use, because the free account has a quota on compute space. Even though it gives you a certain amount of money in credits, it will still won't let you do it. So yeah, that's variables. Also, if you have a secret variable, you can put sensitive true, and what that does is in Terraform we have something called state. So at any one time, you know what infrastructure you have in Azure. If you want to roll back or you want to change, it's all managed by state, and I guess you don't want the secrets in that state because people would go see that. So that's the Terraform variables. We went through provider. You can also have something called outputs. So outputs after you've provisioned the infrastructure. It's essentially, you could want to use these variables further for more scripting or automation. So you can output the variables. So yeah, you can do more automation with it. Or like for my case in this demo, I just want to show the Kubernetes cluster and certificate, so then I can connect to it afterwards. So that's sort of the basic files of Terraform. Now we'll go over automating this. So first of all, we make the resource group. Very simple, so you can see it. This is all Terraform's done, so it's just calling this module here from Terraform, and I'm saying that I want the location to be Australia East, and that will go create my resource group. I then want to do the networking, so I just have one VNet and then one subnet. If you use like application gateway and things, you can do like other subnets, and you can have as many as you want. So one thing in Terraform as well is that, see here, because I've created the resource group here, I then specify, I can specify that here and use it again. So Terraform's smart enough to know, okay, I've now created the resource group, and then I want to use that resource group name or properties in my next resource. So that's one way you can reference other resources that you've just made in Terraform with code. So yeah, so we'll do the network, and then main here. I'm just for this purpose creating a namespace, and then API secret as well. So I'm just going to ask to import that, and then that will create a Kubernetes. Normally, you wouldn't really do that. You could have like Azure DevOps. You would have like a variable, secret variable there, and then you can enter that in your pipeline. But we don't have time today to go over pipelines as well. So, and then here's my cluster. So this is probably the main thing that we should look at. So this is the Kubernetes cluster. We specify the location, the resource group, the version, which is back in the variables as well. And then, yeah, the node resource group, that's going to give us, the size of the disk size. We can change that if we want as well. We can increase the nodes or decrease them as we want. And then I also have AD as well. So that's pretty simple. In the README, it's got all the instructions of what we need to do as well for this. So let's get started. So to make it easier, this will have to be a distinct name. So I'll just put like AKS React name. You can change it if you clone this repo. I'm using a Mac, by the way, as well, but it should be the same. So I'm just using this export name, so it's easier for you guys as well, for you guys and girls. And then over here, let's say we want to make, we can change this as well. So let's just call it Terraform state. So that's succeeded. So we've made the resource group here. So I'll just change it here as well. Then we'll write the storage account. And then the already taken. Okay. And let's change it again. So that's just saying, because you need to be very distinct. So I'll just put 1, 2, 3, see if that works. And then that would have been done. So and that's now running and creating the storage account, and how we can reference the remote state is in the provider as well. So see here, we just made the resource group with the CLI, and we're going to say, okay, Terraform, give me my state file. It's in this resource group, this storage account name. So now I change that to 123, and then I'll just keep the same container name because that doesn't really matter. Normally, I don't really put this under infrastructure as code in case someone deletes it or something. I find it just easy to create it with CLI. So now we're good to go. We know that we have the storage account, we have the resource group, and we have the container. So Terraform will make that state file. So one thing that I'll do on my other screen, I'll need to now get with the storage account, we'll now need to get the access key, because when we initialize the state from my computer, that will then have access to go do that. So I'll just quickly get that now. The one that we just made. And then we'll call that resource group Terraform state. So I'll just answer some questions as well. So what's the difference between Terraform TBars and variables? So the difference between the TBars is that they're essentially, you can override the other variables. So you don't actually need that file, but that's something that you can override the variables. So you don't actually need the TBars, you can just have variables and you can have defaults. So I guess essentially the TBars will just override it. And then Sarah, I think someone asked to turn off the speaker video and no, hopefully.
Yep, all done.
Okay,
Thanks.
awesome, thanks. Great. Sorry about that, guys. So I'm just getting the password now, and yeah, please ask more questions if you have any. And then, so now I've just got the access key. I'm going to put this on the screen because we'll be deleting it after anyway. So here, see I put export. Now we're going to come down here. We've already got the storage name as a variable. So this is the key that I've just got from the storage account. I went to access keys, show keys, and key one. It doesn't matter if it's key 1 or 2. So I'm going to export that. And then you'll see here, the next command that I'm going to run is, so that there's probably about four or five commands that you can use in Terraform. You can use init, plan, validate, and apply. So what init does is it initializes Terraform. So it will call out to Terraform, download all the libraries and modules that it needs to create these Azure resources. So we're initializing it and we're making that state file in the storage account. So I'll just show you down here. So essentially what we're doing, we're initializing, we're using a backend config, which is the storage account name, the backend, the container name, and then the state file that we want to use. And then this can be up here as well. And you see here what it's doing is it's initializing the provider plugin. So it's downloading everything that we need. That will, if we keep updating Terraform as well, that will give us the new versions. So I think I'm a couple versions behind, but that it'll still work if you're on a new version as well. So now you can see that Terraform has been successfully initialized. So we know that that sort of does a bit of code linting as well. So we know that we don't really have any issues. We've downloaded all the modules that we need. They're all good. So now we're ready to do the next thing, which is Terraform plan. So what plan does is it will go look at the state. It will then check Azure to see, okay, is this the same as what we have in Azure as well? So Jay's just saying storage account name is wrong. That's on, yeah, you're right. So storage account name, thanks Jay. AS, yeah, cheers. If I had a prize, I would give it to you. Next time we'll have to get some prizes. Okay, so let's get rid of this. And then, so we'll just go over that again. So yeah, we're storage account name, container name, and then key as well. So the key doesn't really matter because that was made before in it. And then now we'll do the plan. Okay, because we changed the backend, now we'll have to initialize it again. So should just get that. Whenever you add new resources and services, you generally have to initialize it again, just if it needs to download something or it needs to configure what Terraform the backend. Okay, so initialize, and now we'll do a plan. So that's going to go check Azure for me and see, okay, so this is, and Ben, you asked a question before regarding the TBars. Notice here that because I don't want to hard code my secret in here, I choose not to put it there, and it's sensitive. So therefore it's going to prompt me for it. So you guys will see this on my screen, but it's going to be changed anyway. And then that's going to input the variable, and then so now it's going away and it's reconciling what I have in the cloud now, which is nothing, and then it's going to write a plan saying, okay, I'm going to now provision all of these services. So let's go from the top. So you can see here, it will let you know that this is what's going to run. This is really good to check this each time as well, in case you accidentally delete something. Like I've heard of some problems where people have VMs and they increase the disk size, but they delete all the data by doing that. So there's some things that you need to be aware of. So because this is the first time I've run, this is just showing this is all the stuff that we need. So we're doing a cluster, and then we can see here that resource group, virtual network, subnet, all the stuff that we have in the files here that you'll be able to try on your own later if you want. So now I'm happy with that. You can do validate as well, but I'm not going to bother. But so now I'm going to apply that. So applying it's essentially the same as plan, but it will actually say, okay, I'm going to do all this stuff. Do you confirm? And I'll say yes. And then Terraform will go and provision those resources. And I guess because I'm doing it on my computer, I did a AZ login as well. So I'm logged into the Azure CLI as well. So it will say, do you want to, so I've got 10 resources or services to add. So I'll say yes. And then that's going to go create all of the files. So that's creating them in Azure now. And that's adding it to the state file. So one great thing about Terraform is the state file. Some people disagree, but So yeah, that's provisioning all my resources. It's getting my cluster ready. So now that we're waiting for that takes probably like 8 or 10 minutes. So we can go over to the .NET API now. So here you can see this was actually made on a Windows computer. I just used the create new project, and then I specified with Dockerfile. So you can do it on a Mac as well. You just .NET new. It's good on Windows. On Visual Studio, it will give you, like, if you want to use auth and stuff, and it does all that templating for you. So this is pretty much the standard template. It's a Weathercast API. I just changed it to a Surf API instead of Weather. So yeah, we just have the standard controller. One thing that they've changed in the startup is, so in Kubernetes you have a concept of readiness and liveliness probes. So because Kubernetes is an orchestration tool, it's essentially probes that will say, okay, are you ready? If yes, then that's great. You keep going, and it will check the health to see that the API is still working and functioning. You can actually make these better as well. That, one of them could actually do a call to the DB or something to know that you're actually working. And then if it's not working, Kubernetes will then delete that pod and then go spin up another one with the same Docker image, and then it's all done for you. So that's a library. Let me check. Using this one, diagnostics.healthchecks, and then all you do is you add health checks in the startup, and then you just specify the endpoints there as well. And you can, this is the very basic part of it, but you can highly customize them. So I won't bore you too much about the actual .NET API. We'll probably go over the Dockerfile more importantly. And then we'll go over the Helm chart as well, because we'll run out of time pretty fast. So I've got a README in here as well that I'm still working on. You can also, in Azure CLI, once you've made your new cluster, you can actually use the CLI to import that into your kube config. So that essentially on your local computer, it knows where to point to the cluster. So you can use that as well. So this Dockerfile is just made by the template as well, which is great. So it's going to use the base image of the .NET ASP.NET. You can use other ones like the Buster Slim as well, but in this case it gave me that. And then I'm going to build, so it's restoring my project, and then building the project, and then publishing those files into the container, and then this is my entry point. So yeah, pretty straightforward. And then once at the moment I'm using Docker Hub because ACR would have taken a little bit longer, just in case there was any errors on a live demo. So to build this, we go Docker build, and then you have to be in the same directory as the Dockerfile. That will build your application and then publish it into a container image. And then we can tag it as well. You generally wouldn't use latest, you'd use like a commit char or something more meaningful, because it's always going to be overridden with latest. And then you push that to Docker Hub as well. So then you can use this template if you want to fork it from GitHub as well. So now I'll push that container image up to Docker Hub, and you can do the same for ACR or wherever. It's pretty much the same. So that's, if you have any questions, anyone has any questions about the .NET 5 stuff, let me know and I can cover that now. Otherwise, I'll move on to Helm. In summary though, we have a Dockerfile, and then we change some stuff. Yeah, just a couple of lines for the health checks. We don't need health checks, but it's always good to have. So now we'll move on to the Helm. So for those of you that don't know Helm, if you haven't used it, or if you haven't used Kubernetes deployments first, I recommend writing it in YAML first. Otherwise, you'll confuse yourself, because Helm essentially is just Kubernetes deployments, but it allows you to have variables. So I've just made some two basic. So I've made one deployment. So here in the deployment, you can see that you can have as many replicas as you like. You can have 3 if you like. What replicas means is you can deploy the API 3 times. So there'll be 3 instances of it, and then the service sitting over the top of it will act like the load balancer. So we'll go into service soon. So yeah, Kubernetes also has really great documentation on this for deployment, services, pods, everything. If you want to get started, you can also use this template if you want to go fast. So we have namespaces in Kubernetes, which is isolated environment. Think of it sort of like resource groups in Azure. And one thing, so I have values here. So this is similar to the Terraform variables file as well. So this makes it easier for deployments and for people that don't really know much about Kubernetes. They can come into the values and say, okay, well, now I'm changing this image, or I want to add pool secrets if we used ACR, or I want to change the ports. And then this is just your standard Helm charting. So normally Helm chart will just have the folded chart. It'll have templates with your Helm ignore, similar to a Docker ignore as well, which we have done there. Standard helpers, so that overrides the names. And then, you can see here that, so this is looking at values.container.image. So I'll say, this is the values file, container image, so just all YAML. And then this is our service as well. So you can write, there's three types of services you can use. You can use node port, cluster IP, load balancer. Generally, I use Nginx for ingress, but you can, if you don't know too much about Kubernetes, you could just do a load balancer. And then if you specify type load balancer here, that Kubernetes will then talk to Azure through the operator, and then Azure will actually provision a load balancer for you, and then it will point into that service straight to your app. So here we can, let's use Helm and show Helm deployment as well. So let's make sure the review is up to date. So we've got Helm installed here. So make sure that, we're in the file where you can see chart, and then Helm install reactor lab chart, and then setting that with the context that will then deploy that Helm chart. So if I now go use the kubectl, and then I watch that, that'll go out and be deploying at the moment. So you can see I have 3 replicas running and then a service as well. So that will take probably a minute to spin up. And the liveliness probes that we made in the startup are actually working if we look at the deployment as well. So you can see here, liveliness probe is ready and health, and the deployment is pinging that to say, okay, are you ready? And then it's saying yes. So now we're all running. So we have the API is up. So you can see that we have a service, and then we have our deployment. So a deployment is, so the lowest level is a pod. Your container, the API container that we made, will sit inside the pod. and then the deployment will specify things like how many pods that we want and how many, all the environment variables and all. It's almost, yeah, it's a deployment. So do we have any questions so far on this stuff? Is there any, I know it's quite a lot to cover in one day, but if there's more that people want to know about a certain thing like Kubernetes or Helm or Terraform, .NET, let me know and I can drive the talk based on that. So yeah, we can see these again, and then if you want to do logging as well, you can see the logs working. Reactivate. So you can see that we don't need to worry about that anyway, because the TLS will be terminated at the load balancer. So yeah, that's pretty much how you can deploy a cluster using Terraform, make the API, and then deploy the API using Helm. So probably finished a little bit early today, Sarah, but yeah, if anyone has any questions, please let me know. If you do want to follow the lab that I made and you're having issues, just let me know as well, and I'm more than happy to help out. But I hope you enjoyed the fast overview of how all those things work.
Great, thanks, Brad. I think we've got one question coming through from Jay in Seattle. If you want to check that one out quickly.
Yeah, sure. Yeah, thanks for asking, Jay. Okay, sure. So the release. So release name. So this is like a normal Helm thing. Helpers. Release name. So I believe release name is actually if we specify. So when we went Helm install React lab, that would be the release name. And then what this helper does is say, so if I go Helm list, the release name will be React lab, which I specify. And then this is a standard Helm thing. So that would say, okay, if this person specified a release name really crazy, I'm going to truncate it to 63 characters and do that. But essentially, you generally don't have to worry about that. It's more for metadata to track deployments, and that could change the versions or environments or different. Yeah, essentially, it's just metadata that comes from when you go Helm install.
Great, thanks, Brad. Was that the question answered there?
Hope so.
Great. All right, so no questions have come through at this stage just yet. So I'm just going to share the slide there. You'll just see I've shared in the Q&A section as well the link to the survey, and with the event code you'll see there. And then also I've shared a link to upcoming events on our Sydney page. If you just go to the general page for anybody that's in the States, our general Microsoft Reactor page, you'll be able to see your local events as well. And then there's a YouTube channel. So this one will be uploaded to YouTube in the next 24 to 48 hours. Oh, I think we've got a couple of questions that have come through.
Awesome.
Jay in Seattle said, yes, thanks. And then I'm just going to publish this one from Ben. Can you see that one at the bottom there, Brad?
Yep, I can see it. So is the parenthesis syntax standard YAML feature, or is it Kubernetes syntax? Similar with them. Yeah, so that's a Helm. Yeah, it's a Helm feature. So I guess it's just, yeah, it just substitutes the variables. So think of it, if you see like in the controller here, think of it like using that and then the dollar, and then the parenthesis there to say that this is a variable, treat it as a variable, and don't treat it as a string. So yeah, just a common thing for the Helm templating. Otherwise, if we go to where we were, yeah, it would just go up as a string, but yeah, it's a Helm thing that substitutes the variable. And yeah, if you do like this stuff, I'm actually hiring for my team at the moment. So yeah, reach out to me if you're interested in cloud engineering roles as well.
Awesome. If you wanted to maybe share your LinkedIn details, Brad,
Yeah,
now
sure.
in the Q&A section, whilst I quickly wrap up. Thank you everybody for tuning in today as well. Have a good rest of your afternoon, evening, morning, and we look forward to seeing you again for another Microsoft Reactor live stream event. And thank you to Brad. I'll just give you a moment to put that into the Q&A so people can capture that before we leave.
I think I'll just quickly get it. I'll be 20 seconds.
In the meantime, Ben said, cool, that answers the question. Thank you. Thanks,
yeah,
Ben.
I just put it. It's just LinkedIn Brad McCoy 3. So yeah, please reach out if you want to need help to do anything in Kubernetes and Azure as well. I'm more than happy to help.
Great. Well, thanks, Brad. And that is in the Q&A section now. So everyone will say another good afternoon, good evening, good morning, and then we'll see you next time. And thank you so much again, Brad, for joining us.
Yeah, thank you, Sarah.
We'll see you next time. Bye.
See you. Bye.